scipy.curve_fit versus Numpy.Polyfit different covariance matrices. I am using Python 3.6 for data fitting. Recently, I came across the following problem and I'm lacking experience, wherefore I'm not sure how to deal with this. If I use Numpy.Polyfit x, y, 1, cov equals true, and scipy.curve_fit, lambda x, a, b, a asterisk x plus b, x, y, on the same set of data points, I get nearly the same coefficients a and b, but the values of the covariance matrix of scipy.curve_fit are roughly half of the values from Numpy.Polyfit. Since I want to use the diagonal of the covariance matrix to estimate the uncertainties, u equals Numpy.sqrt, Numpy.diagram, cov, of the coefficients, I have 3 questions. Which covariance matrix is the right one? Which one should I use? Why is there a difference? What does it need to make them equal? Thanks. Edit. If I use the statsmodels.api, the result corresponds to that of curve_fit.
I imagine it has something to do with this. As in this case len x order is 4 and len x order 2.0 is 2, that would explain why your values are different by a factor of 2. This explains question 2. The answer to question 3 is likely to get more data, as for larger len x, the difference will probably be negligible. Which formulation is correct? Question 1 is probably a question for cross-validated, but I'd assume it is curve_fit, as that is explicitly intended to calculate the uncertainties as you state. From the documentation. Cov 2D array the estimated covariance of popt. The diagonals provide the variance of the parameter estimate. To compute one standard deviation errors on the parameters use per equals np.sqrt, np.diagram, cov. While the comment in the code for Polyfit above says its intention is more for student T analysis.
The two methods compute the covariance in a different way. I'm not exactly sure about the method used by Polyfit, but curve_fit estimates the covariance matrix by inverting j.t.j, where j is the Jacobian of the model. By looking at the code of Polyfit, it seems they invert LHS.t.LHS, where LHS was defined as the Vandermonde matrix, although I have to admit I do not know the mathematical background of this second method. Now, as to your question of which is correct, Polyfit's code has the following comment. Based on this and your observation, it would seem that Polyfit always gives a bigger estimate than curve_fit. This would make sense because j.t.j is a first-order approximation to the covariance matrix. So when in doubt, overestimating the error is always better. However, if you know the measurement errors in your data, I would recommend providing them too and calling curve_fit with absolute_sigma equals true. From my own tests, doing that does match the analytical results one would expect, so I would be curious to see which of the two performs better when measurement errors are provided.